Now, to understand the concept of the likelihood ratio test and its application, we take a simple example. That is example number 1. Let x1, x2 up to xn be the random sample from the normal distribution with mean theta and variance 1. Consider the testing, that is h naught theta is equal to theta naught versus h1, that is theta is not equal to theta naught. Here theta naught is a number fixed by the experimenter prior to the experiment. Now, what is our objective? Write down the likelihood ratio statistic. So how we proceed for this one? So first of all, according to the likelihood ratio test, that is actually lambda x, which is equal to L hat, that is capital gamma naught into L hat capital gamma. So that is actually based on the null hypothesis, and that is based on the full parameter space. So how we write down this one? So where L dash gamma naught, that is actually equal to 1 over 2 pi raised to power n over 2 into exponential, that is minus 1 by 2 sum xi minus theta naught here, because it is based on the null hypothesis, and the likelihood function, which is based on the full parameter space, that is L hat capital gamma, that is 1 over 2 pi raised to power n over 2 into exponential minus 1 over 2 sum xi minus x bar square. Now the ratio, which is lambda x, so you can see that these two constants are cancel out. So the rest of the things we have, that is exponential, that is minus 1 by 2 sum xi minus theta naught square प्लस जब ये ऊपर जाएगी तो ये प्लस हो जाएगी, so that is actually 1 by 2 sum xi minus x bar square. Now sum xi minus theta naught square can be written as, that is sum xi minus x bar square plus n x bar minus theta naught square by adding and subtracting x bar, and then we simplify this, we obtain this one. So when we put this result into this equation, we, after simplification, we find that this is lambda of x, that is actually equal to exponential into minus n x bar minus theta naught square over 2. So this term will cancel out with this one, and we have this result. So next, so we have to determine the rejection region, the likelihood ratio test. The likelihood ratio test is actually lambda x less than or equal to k, where k is determined by the size conditions. So exponential minus n x bar minus theta square divided by 2 actually less than or equal to k, or we can take the log of both sides, then we find this one minus n x bar minus theta square over 2, that is less than or equal to log of k. Further, we can simplify this one, that is n x bar minus theta square less than or equal to minus 2 log of k. So let's say we call it k1. Now to find k1, we need to apply the size condition. So what is the size condition actually? That is, you know that is actually based on type 1 error, and that is actually equal to alpha. And what is type 1 error? You know that is reject H0 when it is true, and that is actually equal to alpha. So in this case, how we proceed that is actually probability, that is n x bar minus theta naught square less than, that is actually less than or equal to k1, and that is actually alpha. So, and that is actually based on under the null hypothesis. So we need to actually find the distribution. Now we need to find the distribution of n x bar minus theta naught square. So how we find the distribution of this one? So considering the original xi's, and we know that it follows from the normal distribution with mean 0 and variance 1, then we know that x square is follow the chi-square with 1 degree of freedom. We have already proved this one. So in this case, under root n x bar minus theta naught, it follows the standard normal distribution. Then on the same line, the n x bar minus theta naught square follows the chi-square with 1 degree of freedom. So hence the test is reject H0 if the n x bar minus theta naught square follows the chi-square with 1 degree of freedom. Otherwise, accept it. So that is actually the procedure how can use the likelihood ratio test and how we can determine the critical region and so on.